All right, so just as a reminder, a combination of numbers, variables or letters, and operation symbols, right? So things like adding, subtracting, multiplying, or dividing, as well as even grouping symbols and things like that. Parentheses, fraction bars, those are all fine too. Is called an algebraic expression, or often we'll just say expression. So sometimes we'll leave off that word algebraic. And examples here be things like 2x, the number 5, x minus y, x squared plus 4 over y, etc. And what you want to remember, the thing they don't have is that there is no equal sign, right? So we save that for our equations, which we're going to be doing for quite a bit in the next few videos. So we're kind of working with the beginning part here. And don't forget as well, as another reminder, when two things are touching, something like 3y, this is the same thing as 3 times y, right? Or if we have xy, it's the same thing as x times y. So if there is no symbol, it automatically means multiplication. And same thing is true with our exponents. If I have x to the 4th power, that is x times x times x times x. So again, things we already know, just kind of reminding that we can apply those techniques as well now to negatives and also to variables. Okay, so let's do a few more definitions. Okay, so our first new definition is about the word term. So the add-ins of an algebraic expression are called the terms of an expression. So basically, terms occur in between the addition signs. So for example here, so let's say we have the expression y plus 5. This is a term, and this is a term. So we say that this has two terms altogether. So 3x minus 4y plus 1. Now, if you have subtraction, you still have the terms there, but we usually keep that subtraction symbol with the number. We make it a negative. So when you see subtraction, what you can do is rewrite that. So 3x plus negative 4y plus 1 is the same thing. And now you can just see your terms a little clearer. So 3x is one term. Negative 4y is the other term, so that negative is with the 4y. And then 1 is your last term. This is an example that has 3 terms. And something else like maybe just negative 4y squared. So here there are no plus or minus signs. This is still a term, and this is an example where you have one term. And so on. So I can make these as long as I really wanted to. I could do an example as complicated as I want. So here you have examples of just 2, 3, and 1 term, just to kind of see what those look like. couple more definitions here. Okay. So another definition is a term that is only a number is called a constant or constant term. So example, let's say I had 4x plus 6y plus 3. So this right here is your constant or constant term. Okay? Not every example has to have one, but if it's only a number, so no variable, right, then you have a constant term. Usually we just say constant. So if you hear someone refer to the term constant, that's what they're looking at. A term that contains a variable take a guess, is called a variable term. And honestly, that's a phrase I don't use very often because they just occur so much. Usually we tend to point out things that are constants, but if it doesn't have just a constant, then it is a variable term. So these two are both examples of variable terms. Okay, another definition here is a numerical factor of a variable term is called the numerical coefficient. So this is, i.e., the number with the variable term. So that's all we're referring to. We say numerical coefficient. We're just saying what's the number with the variable term. So for example, let's say this is the term and we're looking for the coefficient or numerical coefficient. Usually we just say coefficient. Okay. So for instance, up here, if my example was 4x, then the coefficient is just 4. If it was 6y, the coefficient is just 6. If you have something written in, maybe you just have an example where it's just an x, there is a number out front, there's always a 1 being multiplied. So this is the same thing as 1x, so the coefficient is a 1. Or if you had a negative x, this is the same thing as negative 1x, so the coefficient is negative 1. We often don't put in coefficients of 1, so if you don't see a number there, it is there, it's just hidden. Or if I have the example negative 3z, my coefficient is negative 3. Okay, so your coefficient or your numerical coefficient is really just the number out front. All right, couple more definitions. I know there's a lot of definitions in this section here. Like terms. Like terms are terms with the same variable factors. Are called like terms. And then terms that are not like are called unlike terms. So let's go through some examples here as well. So I'm going to make it 2 columns of like terms and then unlike terms. So Like terms have the exact same variable factors, so the exact same variable components. So things that would be like terms could be something like 4x and negative 5x, right? They have the same exact variable. Or 2x squared and 3x squared. Again, they have the same exact variable factors. They both have x squared. Or maybe I have something like x, y, and negative yx. Now, this one's a little tricky, but again, I don't care about the sign. I don't care about the numbers. Just looking at the variables. Do they have the same factors? Well, they both have an x and they both have a y. So they do. The order doesn't matter because multiplication is commutative, right? If I do 2 times 3 or 3 times 2, I get the same answer. So it's okay to switch the order. Usually you'll see things in alphabetical order, so you'll tend to see this instead, but they are like terms. And how about one more? What if we did 4x squared y and negative x squared y? Okay, so again, they both have the x squared, they both have the y. So they're exactly the same for the variables. Things that are unlike. One example could be 4x and negative 5y. All right, so these have totally different variables. So they're not like. I could also do something like 2x squared and 3x cubed. Those are unlike because they have different powers. Okay. Now I know they have the same variable, but this one has 2 x's and this one has 3 x's. So those are different things. We can't count that as being exactly the same. They have different powers. Another example like this could be 4x squared y and negative xy squared. Now this one is probably the trickiest one because it looks very similar to what I gave you here, but notice that there is a change. Here you have x squared y, whereas in this case you have x and y squared. So you have changed the powers. The power has moved spots. So this is another example where you have different powers here as well. So even though they look the same, because this one has 2 x's and this one has 2 y's, they are different. They are not the same. So these are unlike. And the reason we care so much about this, and that is because we can add and subtract like terms, but not unlike terms. And this is really where we're going. So that's why we care if something is like or unlike, is because if they're alike, then we actually can combine them together through addition and subtraction. All right, and I do want to recall one more property here, or I guess a couple more, but we're going to just do it quick. We do use the distributive property a lot. So the distributive property says that if you have A times B plus C, then you can distribute that A throughout, and it's multiplication. So you have AB plus AC. This is, again, A times B, A times C. And it also works the other way. So if you have the B plus C times A next, you can bring it in this way. So BA plus BC is fine. And you can also do it with subtraction. Oh, sorry guys, I made a mistake here. I should say CA. I apologize. That looks better. So we still have that same distributive property. And again, we've seen this before. And other examples as well, things that you want to keep in mind, is that addition and multiplication are both commutative and associative. Okay, so remember, commutative means that you can rearrange the order. Something like 2 plus 3 and 3 plus 2 are the same thing. Also works multiplication. Associative is about the grouping, so you can regroup as well. Again, if it's all addition or all multiplication. So I'm not going to rewrite all those down here. Again, just a reminder that if you have just addition or if you have just multiplication, you can rearrange things, and that's perfectly fine as well. All right, so let's look at some examples. Oh, I guess I have one more definition. So when you hear the phrase combining like terms, we often use that in exchange for saying adding or subtracting like terms. So if someone says to you, or an example says, hey, combine those like terms, it just means to add or subtract them, whatever the problem indicates. An algebraic expression is simplified when all like terms have been combined. So again, sometimes you'll hear someone also say simplify the expression, and that also means to just combine those like terms or add and subtract those like terms. All right, so let's do a couple examples here. So I have 3x plus 5x, and we're going to say simplify. Fine. Now, what's going to happen is that you are just going to put like terms together. So notice that these are like terms here, right? They both have an x. So I can just do 3 plus 5. 3 plus 5 is 8, and the x stays. So what happens is you add or subtract the coefficients, which are the numbers out front, and then you keep the variable part the same. So when you see simplify, when you see combine like terms, when you see add or subtract, that is what you're doing. If you have like terms, they can go together, and you're just going to add or subtract as you would think, right? So 3 plus 5 is 8 here, but the x stays the same. It does not become x squared. So it's kind of like with units. If you add 1 inch plus 2 inches, you get 3 inches, right? We don't get squared until we start multiplying them together. So it works just like units here. Now, technically what's happening, and I don't expect you to do this every single time, but technically what's happening is you are actually applying the distributive property here. So notice that I have an x in common. So if I were to take that x out, I could rewrite this as just 3 plus 5 with the x removed, right? I haven't changed the problem because I can bring that x back in. And now I can kind of clearly see that there's the 8, and my answer is just 8x. So we're actually sort of applying the reverse distributive property here to get the reasoning why we can combine like terms. So I just want to point that out, but realistically, I don't expect you to do that every single time. You should be able to look at an example, see what like terms are, and just combine them together. So what if I have y minus 3y? So again, these are like terms. They both have y's. So they both have exactly the same variable parts. And what you do want to remember is that if there's nothing in front, there is a 1. So this is 1y minus 3y. Now, what you can also do is remember that subtraction changes to addition, and then that 3 becomes a negative. So I'm applying my sign rules too now. So it's all starting to get combined together. 1 plus negative 3 is negative 2. and then that y just stays. All right, we're going to do a few more examples of this. This is a really important topic that we're going to come back to over and over again, and we're also going to use it in solving equations as well. So here I'm just going to kick it up just a little bit, and I do see some like terms, right? I see these pieces are both x squareds. So I'm just going to highlight my like terms. The -5 is not a like term with that. That is a different kind of thing, right? That's just a constant. So it's not going to get combined. So I'm going to do my like terms first. Here I have 4 plus 6, which is 10. And then the x squared stays the same. You're going to bring that -5 just right down. Now, these are now unlike terms. So we cannot combine them. So our final answer is 10x squared minus 5. We're going to have to stop. Let's do another example. Again, kicking up a little bit here. So when we combine, we're looking for like terms. So what do I see that's like? I see a 2y and a 4y. And I also see two constants, right? I see this -6 and this -3. So we're going to combine them together. Now, you want to be careful. When you see subtraction, and we're going to start combining things, we do need to change it to addition first because you're not allowed to rearrange subtraction. As you get better at this, you're going to see that subtraction is just a negative. So those of you who are good at doing math in your head may just jump right to that now. But if you're not there yet, you're going to change all your subtraction over. So this becomes addition, +6 becomes -6. This becomes addition, +3 becomes -3. So what I'm doing is I'm making sure that sign stays with the number. 6 is negative, 3 is negative. So you're going to start to see that subtraction signs are just negatives. So here I have 2y and 4y. 2 plus 4 is 6. And then here I have a -6 and a -3. -6 plus -3 is -9. So this is my answer. Or if you prefer, you could write it as 6y minus 9. So adding a negative and subtraction are the same thing, remember. You usually go from this to this, but you can go the other way too. So either answer is correct. Okay. But here's where students get mixed up. You need to watch your signs. If you see subtractions, change those over to addition and change the following sign. That's going to make things much, much easier for you. All right, let's do one more example here. And then we'll move on to some harder ones. All right, so again, kicking it up a lot here. We want to be careful. So I do see a lot of subtraction. So what I'm going to do first, before I even start, is I'm going to go through and I'm going to change my subtraction to addition. It's kind of a good tip to do it right at the beginning if you find you make a lot of mistakes. You don't have to, but some students find it easier. So I'm going to take any subtraction and change it to addition and change the next sign. So +5 becomes negative. Here, change it to addition, +3 becomes negative. Here, change it to addition, +7 becomes negative. Here, change it to addition, and then -2 becomes +2. Now, if that's too messy, you can rewrite it, which I do recommend as well. So let's look for our like terms. So I see a 2x here, and I see a plus x here, so that would be a 1x. So I'm going to combine those first. 2x and 1x, 2 plus 1 is 3, so I have 3x. Now I'm going to do my y's. I see a y here and a y here. So I have a -3y and a +2y. Negative 3 and positive 2 is going to be negative 1. So I can write negative 1y if I like. And then I do see my numbers, my constants. So I have a negative 5 and a negative 7. Negative 5 plus negative 7 is negative 12. So plus negative 12. Now I cannot combine anything else. These are different things, so I can't combine them. Now this is fine for a final answer, or if you want, you can clean this up a little bit. So plus and negative is the same thing as minus. And we don't typically put the 1 in, so you could also write it as minus y. And then here, plus and negative is also the same thing as minus. So both of these answers would be acceptable and are correct. All right, let's keep going. I'm going to kick it up a little bit now and start bringing in some multiplication as well. Now, when you multiply, you do not need like terms. So make a little note here. Multiplication does not require like terms, only adding and subtracting. So let's say I have something like this. Let's do example 5 times 2y. So again, I don't have like terms here, but it's okay. For multiplying, you're just going to multiply the numbers out front in this case. 5 times 2 is 10, and I just have 1y. Or maybe I have negative 2 times 3x squared. Negative 2 times 3 is negative 6, and I just have an x squared. Okay, so I do not need like terms of multiplication. Let's bring in some distributive property again. Here, again, I have a parentheses, but I cannot actually add anything on the inside of those parentheses. They're unlike terms, so I have to use the distributive property. So I'm going to take that 5, I'm going to multiply it through. So I have 5 times x plus 5 times 2. And if you can do this in your head, that's absolutely fine. So I'm going to get a 5x, and 5 times 2 is 10. Now these are different terms, so I cannot add or subtract them anymore. I'm done. All right, let's do another example. Again, inside the parentheses, I have unlike terms, so I can't add or subtract. I have to use the distributive property. You do want to be careful here. I have a negative 3, so the negative 3 is going to get distributed. So another thing you can do too is if you see a minus sign, sometimes it's easier just to change it over right away. So I'm going to make this adding and then a negative 1. So I have negative 3 times 4a plus negative 3 times negative 1. Negative 3 times 4 is negative 12, so negative 12a. Negative 3 times negative 1 is positive 3. These are different, so I cannot add or subtract. As a little side note here, if you didn't change over that subtraction, you would still get the same answer. So I would still distribute through negative 3 times 4a, and then I'd have a minus, and then I'd have negative 3 times 1. So what you would get is negative 12a, and then here, those two negatives would cancel out. So you would change it over now, adding a positive at the end. So you'd see those two negatives going to cancel and give you positive still. So you're still going to get the same result, even if you leave the subtraction sign in and you change it over later. All right, let's do a couple more of these. Again, kick them up a little bit more now. All right, so I'm going to do 4x times x minus 2. right. So again, this is a good time if you want to pause the video and try these out. Here, again, I'm going to use the distributive property. Now, notice I have 4 times x, and the whole thing is touching the parentheses, so I'm going to multiply through the whole thing there. So I have 4x times x, and again, I can change over my subtraction to plus and negative, whatever you find easier. And then I have 4x times negative 2. Now, let's think a little bit here. X times x, well, I have 2 x's, so that's going to be x squared. And then 4 times negative 2 is negative 8, and just the 1x. Now, I cannot add these because these are unlike terms. One has an x squared, one has an x, so they're different. So this is fine for your final answer, or if you had it as negative 8x, or sorry, minus 8x, that's fine too. Adding a negative and a minus are the same thing. Here, I have a minus 2y that's being multiplied. So I have minus 2y times y squared plus minus 2y times 1. Here I just have negative 2, and then a y and a y squared. That gives me 3 y's altogether. 1 here and 2 here. This becomes y cubed. Negative 2 times 1 is still negative 2, and still the y. So this is fine, or this is fine. So adding a negative and subtraction are the same thing. We'll start getting used to that and be able to just naturally go back and forth between the two forms. All righty, let's do one more here. So I have 2 sets of parentheses. I cannot do anything on the inside, but kind of like regular PEMDAS or order of operations, we still have to do parentheses first. So if you have distributive property, you're going to start there. You can't actually combine any like terms yet because you have to clear out those parentheses first. So that's going to be our first step. So here I have a negative 2, and I'm just going to start through. I'm also going to take this minus sign and change it over to adding a negative 4. So I have negative 2 times x, which is negative 2x, and then negative 2 times negative 4, which is positive 8. If that's going too fast for you, then you're going to just slow down a little bit. You're going to write out that intermediary step. Now here you want to be really careful. I see a minus 3. So I'm going to change this to adding a negative 3. And that negative has to get distributed. So if you see a minus sign again, change that over so you know how to distribute. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. Again, if this is too fast for you to go right to the answer, then you're just going to take your time and write that middle step out. Now I can combine like terms. So let's see, I see x is here. Negative 2 plus negative 3 is negative 5, and the x stays. When you go back to adding and subtracting, do not change your variable. That's a very common mistake, okay? So up here, I was multiplying. Y times y squared is y cubed. I do change my variable. But when I'm adding or subtracting, we do not change the variable. So it's negative 5x. And then here I have a positive 8 and a negative 3 that are being added. So this is positive 5. And just a little side note here as a reminder, if you have a negative sign in front and there is no number, you can still put a 1 there, or you can just distribute the negative, whatever you find easier. But there is a 1, so you can always put a 1 in. And then when you distribute, you have negative 1 times x plus negative 1 times 2. So negative 1x plus negative 2, or negative x minus 2. Both of those would be correct ways to write this. All right, let's do one last example with an application this time, or a couple applications. So how about we find the perimeter of the triangle. So maybe I have a triangle here. And maybe this side is x feet, and this side is 3x feet, and this side is 5x feet. And again, I'm just making up an example here. So remember, perimeter means to add up all sides. So what I could do here is my perimeter is equal to x plus 3x plus 5x. So even if I bring in variables, I can still add up all sides. These are all like terms, and there is a number 1 out front here if you want to put that in. So 1 plus 3 plus 5 is 9. And don't forget, for adding and subtracting, the x just stays. Don't add up all those values. And this is in feet. So I have 9x. All right, so maybe I want to find the area of a rectangular garden. So maybe one side is 10 feet. And the other side maybe is 2x plus 4 feet. Now remember, the area of a rectangle is your length times your width. So here I have my length of 10. I have my width of 2x plus 4. So this is a great example to use that distributive property. So I have 10 times 2x plus 10 times 4, which gives me 20x plus 40. These are unlike terms, so I can't go any further. So that's my final result. But do keep in mind here, you have feet and feet. So when you multiply feet times feet, you get feet squared, or you can write that as square. So remember, when we're multiplying, I don't need like terms. I can multiply pretty much whatever I want. But when I am adding or subtracting, I do have to be careful that I have like terms here and that you're not changing the variables or changing the units. So we only multiply the variables or units when I have, or square them, I should say, or cube them when I have multiplication. So you just want to keep that in mind, as that is the biggest mistake students make when they get to these harder problems, is they make mistakes going back and forth. So when we multiply, we can change the variables, we can change the units, but when we add or subtract, we cannot. So that's the one really big piece of advice that you want to keep in mind here as you're going into more complicated examples.